In this chart, we are going to be looking at some of the characteristics of growth and decay, and those are for exponential functions. We're going to do that by going back and looking at the examples that we have of growth and decay functions. So I'm going to go back in my notes here, and I want to look for where I had exponential growth. So this was exponential. I can see my NPAT formula, but I see that the graph is decreasing. So this is decay. This one was linear. This one is growth. So I'm looking at this example to determine my conclusions that I have. The first thing that my chart asks me is what is happening with the change in Y values. So when I look at the change in Y values, that's up here in the chart, change in Y, and I see it's 155, it's 4,960, it's 158,720. So I see that it's really getting bigger. It's obviously not constant. They're positive, so they are increases in Y, and they get bigger as I go across. The next thing I'm asked to look at is the Y ratio. So in the Y ratio, I notice that it is constant, and at 32, it's significantly greater than 1. When I look at the word problem for this, I have to go back further in my notes. And so if I go back further in my notes, I have this first example where we took a job in healthcare, and I see here that the problem would use words like increase. In this case, it uses the word raise, something that grows. And I see that the way that I get A is I do 1 plus the percent as a decimal, which is 1 plus R. So the last thing that we're asked to look at for these, I'll go back here, is the graph. And so when I look at this graph, it is concave up. It is increasing at an increasing rate. So I want to go back and write down all those observations that we have. So the first thing we looked at was the change in Y values. They started out very small and they got big quickly. So the change in Y values, first thing I noticed is that they're not constant. Second thing I notice is that they're increasing. And that's that positive. At an increasing rate. And that's that idea that they got bigger each time. I don't really have room for that. I'll put an arrow down here. The change was bigger each time. And it was very dramatic with the example that we looked at. So the change started out in the 100s, then it was like in the thousands, then it was in the hundreds of thousands. So really big jumps in the amount of change. What do I notice about the Y ratio? Well, I noticed that it was constant. And I also noticed that it was greater than 1. Our Y ratio in our example was 32, so significantly greater than 1. In word problems, I'm going to see words such as grows, increases, or in the word problem we had, the word raise. How did we get A from that word problem? Well, we used 1 plus the percent as a decimal. That was the formula that we had of 1 plus R. When we think about A, the A is the 1 plus R. or when we have data, it is y2 divided by y1. We can get that a value in the NPAT formula either way. So because this is exponential, that's where we're using the NPAT. And so that is talking about the a that is the base in that NPAT formula. We also know that when we do this math, either way that we do that, our answer, and we said this before, is greater than 1. When we look at the graph, it is concave up, and that's true of all exponential. And specifically, this one is increasing, that means it's going uphill at an increasing rate. And that is the same way that we describe the change. So this first increasing is the uphill, and then the increasing rate is saying that it is getting steeper. And that is because those change values were getting bigger. So bigger and bigger jumps as we go across that graph. Now we're to look at exponential decay, and we want to go back and again look at our example. So we had exponential decay in this example. So this is our decay example. It was an NPAT, and it was going down in value. So if I look at my change values here, I see that these change values are headed towards 0. So they are decreasing because they're negative. And then the amount of decrease, so at first it dropped by 4.6, then it dropped by 3.3 if I round that off, and then it dropped by just 2.3. So every time it drops by less. So this is decreasing, and that smaller decrease is that decreasing amount. When I look at the y ratios here, these, I notice, are all less than 1. So instead of using a negative, like negative slope to make things go down, in exponential, we're going to use a ratio less than 1 to make things go down. When we look back at word problems, so we have to go back a couple more slides. We see in the word problems, words like eliminate, that's what we see in this last word problem. We might see decays or decreases. And we see that when we figure out the a value here in the NPAT formula, we're going to then have to use subtraction to get that. Finally, when we go back and look at the graph for decay is still concave up, so that's the curvature, but it is decreasing because it's going downhill, and it's at a decreasing rate, meaning that it's getting flatter. So let's see if we can put all of that together. So the first thing we notice about the change values is that they are not constant. Second thing I notice is that they are decreasing. And that is that idea that they are negative. And they're decreasing at a decreasing rate. I feel like that is the most confusing, but that is the idea of it drops by a smaller amount. What do we notice about the y ratios? Well, we notice that they are constant. And we notice that they are all less than 1. In word problems, we see words such as decays, decreases, and eliminates. From a word problem, we would take 1 and we would subtract the percent as a decimal. Which means that we would do 1 minus r. And then when we get that a is the 1 minus r, or that can be y2 over y1. And when we get that answer, it is less than 1. When we look at the graph, it is still concave up. So that matches for all exponential. However, this one is decreasing, which is meaning downhill. At a decreasing rate. Which is how I would describe the fact that it's getting flatter. And so this chart helps us summarize the things that we're going to see for exponential. Really important that we know how to get that a value, because that a value, the base in the exponential, is kind of like the slope in a linear equation. It's really describing the change and quantifying that with a number that's going to either have our values go up or our values go down following the information that we're given.